Berkeley. And who else? The one in Taipei. Okay. I spent like a month in Taipei. Right. That's it. Who else? Okay. We have a good mix here. First of all, welcome our exchange students. Right. Your presence here liven up our campus. Right. So I hope you can have more interactions with the students in NUS. Right. That's the whole purpose for exchange. Right. And, more interactions, learn from each other culturally, technically, or whatever. Right. Okay, it's 10:10 now. I think we should not wait. In future, our lectures will always start on time. Otherwise, it's unfair to students who can't come on time, right? So we always start on time. Now, this class, I used to run this class even before the pandemic. Similar to this class, I would say. It was okay until last year. Somehow there's a greater proportion of students who don't find it okay, right? They find it too difficult, right? And then I saw some feedback, and then I will do some adjustment. All right, maybe it was indeed a little bit too difficult as far as course project is concerned. Right? Give you some flavor. Last course project was an individual project. Okay. So what I gave them was, in this course, you want to learn how to deal with media. And when you talk about media, it is about, can people back hear me? Is it loud enough? Okay. So media, when you talk about media, you talk about visual, right? Pictures. You talk about audio. You talk about text. You talk about graph, that sort of things, right? So media has got it's very wide, right? So the course project last year, what I did was, I give you a piece of music. First lesson, I'll make it very light. So I tell you some stories also. I grew up watching movies like The Sound of Music. How many of you have watched a movie Sound of Music? No? Right. The Sound of Music was a classic, and there were a lot of nice songs. Okay, and until today, every time I travel on an airplane, if there's this movie, I watch again. So I watch it 10 times, right? I watch it many times. So there are a lot of nice music, and one of them that I like a lot is Edelweiss, right? It's an Austrian song. So I give the music Edelweiss, and I say that on the demo day, I will give you a message, a text message, okay? And you're supposed to encode this text message in the music, okay? And then you play it out. Not just hide in the phone. You have to play it. And then you have to use a computer to record the music from the end, right? And then you're supposed to decode the message. Okay? So that was the project that I did. Some students did it. Some students found it very difficult, right? So I would think that some even hate it. Okay? So my promise to you is, especially for you, those of you who have not come across things like Fourier transform, frequency, because when you do audio signal is an important part of media, right? Speech recognition, all that, you need audio signals, right? You need to know how to process audio signals. If you want to know how to process audio signals, or sometimes images, you must know the notion of frequency, right? Right? And this course is dominated by a concept by someone from France, hundreds of years ago, right? And his name is Fourier, right? Fourier. And then Fourier's teacher was Laplace, right? Fourier, Laplace. We do talk about Laplace, we talk about Fourier. We do frequency analysis a lot, okay? And it's only through frequency analysis, frequency manipulation, that you can do the project that I just mentioned to you just now, okay? You must know, okay, how you encode it, you can use a lot of your creative ideas, okay? Now, to play the air and to record it, right, requires some knowledge on frequency analysis, all right? So my promise to you is, for those of you, especially those of you who have not come across frequency analysis, I think you will learn a lot in this course, right? Now, but in return for learning a lot, it's not going to be easy course. Okay, it's going to be a tough one. And it's only when you learn the tough things that you better off than other people, right? No point in learning all the easy things. Alright? So, the reason I'm teaching you frequency analysis is this. Before I came to NUS, I came to NUS like 10 years ago. I was working in defense research in DSO. I'm not sure whether you know what DSO is. DSO is a defense, it's a research R&D arm for the Singapore military, right? And I was running the signal processing lab. And in my lab, we do computer vision, analysis. And I recruit engineering students, I recruit computer science students also. Every time I see computer science students, I trust them with the algorithm, the coding skills, and all that, but I have to send them for courses. I send them for digital signal processing course because without signal processing knowledge, without the ability to see things in the frequency domain, right? There's half of the work in the lab I cannot let you do, right? For example, you talk about images, right? Images. Images, you know, a lot of things are already used in our camera, right? Images, if you want to, here you have a blurred image and you want to sharpen it, right? To sharpen it, you want to so-called de-blur it, doing the reverse of the blurring process. You need knowledge about frequency, okay? And if you are dealing with speech recognition, audio processing, that sort of thing, you also need the knowledge of frequency. You can run away from it. And not knowing, not having any knowledge in terms of frequency analysis puts computer science students at a disadvantage. Because speech and images is computer science project, that's a subject, right? It's a subject of computer science, right? How can you not know it, okay? So when I came here, I actually told the department that we should teach our students how to analyze things in frequency domain. And they are very receptive to it, and that's why I introduced this class. It is an elective, but at least some students can get benefit from it. Alright? Okay? Who has prior knowledge on Fourier transform? Put it again. Okay, not many. Who are from CEG? Okay. CEG people would have come across Fourier transform, right? Okay. Another thing about this course is, when I prepare the course material for this course, I don't refer to any book because my bachelor degree actually was in electrical engineering, right? And we also learned Fourier transform, the textbook way. And after I graduated, when I went to DSO to do R&D work, I realized that there are still a lot of things I don't understand. Okay, I know how to apply the formula, know a lot of properties about Fourier transform, but I don't really understand a lot of the intricacies. So when I prepare the course material, actually prepare it the other way around. We are going to do things from scratch, from sine waves and cosine waves, dot product. That's it. And then slowly we build up our knowledge. In the end, we derive something, and that something is actually a Fourier transform. Okay, that something was like a few hundred years ago what Fourier taught us. Okay, so we do it that way, and I want you to have a strong grounding in frequency analysis, because once you have the strong grounding, you will know, you will be able to learn other things on your own, right? Anything to do with frequency kind of concept you can learn on your own. For example, some of you may have heard of wavelet transform, right? And any discrete cosine transform sort of thing. Once you have the basics in Fourier transform, you can learn things on your own. Okay, that's the whole purpose of university education, right? Right? To have a strong grounding so that you can fly on your own later. Alright? So, but this year, I think that project, I think that project may be a little bit too difficult for some students, right? So this year, the project will be like that, right? This project, this year's a project, in my opinion, I will do something easier. In my opinion, it's easier, but I'm not sure. Right? But the moral of the story is, when you come to this course, be prepared to rough it out, because it's not easy. Right? It's not easy. So especially when you don't have the background, okay? But my promise to you, as I say, for those who come in late, just now, for the very first class, we delay a little bit, but in future, we start at 10 o'clock sharp. And also, there won't be webcasts, there won't be any recording, right? But my promise to you is, in return, I will spend office hours with you, if you don't understand. Okay? So I will flash some standard slides, right? End-use course materials, ethical behavior, and respecting copyright. You know why we have this? Because there are unscrupulous people who take our course materials and the assignment and post it on the internet to sell. You see that in Carousel, we are very upset with this, because this is an infringement of copyright. Right? Right. So you're forbidden from selling it to anyone. Alright? Because please respect the copyright, and this is a slide that's given to us, and then you should see that in all the other courses. Okay? Do not, you have to respect the copyright. And by the way, this shows up in this list. We actually require students to observe this in our assignment also. Okay? I fail students for plagiarism. Okay? Plagiarism, I fail them. If when you do project, you can get code or you can get some ideas from internet or from any other sources, but please acknowledge them. If you take something that is not yours and you don't acknowledge it, that's plagiarism, and then straight away fail, understand? Okay, if it is a tutorial, very small percentage, you don't fail the course, but you only fail that part of the tutorial, right, that tutorial itself. But if it's like a project, which is a substantial component, you fail. I failed 2 students 2 years ago. Last year, I think we didn't have any. Right, 2 students, I failed them because they copy from each other. Okay? And there are different ways of detecting plagiarism. So it's not just in this course. Next time when you go out to work, when you do research, when you do anything, if you get any idea from anybody, make sure you acknowledge. Right? This is the ethical behavior that we expect from NUS students. Right? So examples of disallow things. No posting on any websites, right, except for the materials explicitly allowed by your lecturer in the respective module. Okay? You want to post anything, you better get my permission, right? And no selling of material, no sharing of questions, answers, which would lead to cheating and plagiarism. Alright? Now, the two I fail. I don't know who copied from who, right? Both will fail. Both fail the course. Okay, even so even if you are not copying, but you your trying to copy, there's no way we can know who copied from who. Okay, so it's just as bad. When you let people copy your things, it's just as bad. So don't do that. Now later on when I'll show you the weightage for the assignment. Okay? Tutorial questions are there to encourage you to practice, to learn. Okay? So I specifically asked the TA who will be grading this in for tutorial. We are not going to pick on very small things and then deduct marks. Right? So that's not the whole idea. It doesn't make sense for people who try a lot and then you make a lot of mistakes and then you get very low marks and then people who don't submit at all get 0, but it's not different from yours, right? It doesn't make sense that way. So tutorial questions are for you to practice. So make sure you practice. If you don't do that, you come back on you in the project and in the final exam. Final exam is 50%. Okay? Final exam is open book, so you can bring whatever you want to bring. Right? Notes or whatever you want to bring. You just cannot bring electronic material. Right? No internet access. Alright? So any questions so far? So all lessons are conducted in person, not online. Attendance is compulsory. Today somehow like I would say 60% attendance. There will be no webcast and no recording of lessons. So this course is highly mathematical and with lots of equations. There are students who, because of the training that we have, they don't like to see equations. And if you don't like to see equations, they're going to dislike this course, right? So my suggestion to you is, if you don't like equation, try to make yourself like equations, right? You cannot do deep work with sufficient depth if you cannot deal with mathematics, okay? But if you still don't like mathematics, this is not the course for you, right? And then you are also expected to do a lot of coding in MATLAB. Now, I know a lot of you are more familiar with Python than MATLAB, okay? In the other course that I'm teaching, I use Python, but for this kind of work here, MATLAB is a lot more convenient. So if you're not familiar with MATLAB, just familiarize with it yourself, and then you find that over during the course itself, you find that it's a lot easier to handle, right? Because there are a lot of good libraries that you can use, very convenient. All right. Now, listen, MATLAB is extremely expensive if you are not in education, right? When I was in ESO, for example, our MATLAB lessons is like more than 10K per person, right? They really slaughtered us, right? In NUS now, a few years ago, our university signed an agreement with MATLAB, right? So we buy the bulk license for everyone to download for free. So please go and download it, right? Please go and download it. It stays in your computer. You can use it for life until your computer dies. Okay? Please go and download it because it's very expensive software, right? And by virtue of the fact that you're anywhere or even exchange students, you can download also. Download it. There are a lot of toolboxes. Just go and download. Okay? Because those it's actually very expensive software. Alright? Now, how many of you are familiar with MATLAB? Okay. Now, again, there's no webcast and no recording. You must attend in person, and in return, my promise to you is if you don't understand, I'll make an effort to see you in my office. Okay? There is no textbook for this course. There are, however, online materials that can serve as supplementary readings, but you must learn to be resourceful to find them, right? There are a lot of materials on what some are not so good, but you make your own judgment, okay? You exercise your judgment. And if you do find something that is interesting, helps in understanding, let us know, let the class know, right? So we can share. Alright? So once again, welcome to CS2108 Introduction to Media Computing. I haven't introduced myself. My name is Kim. NG is pronounced ng. NG is pronounced ng. I'm the third generation Singaporean. My grandfather and grandmother came from China. And they came from China in a province called Fujian. And my surname is Huang. If you see the surname Huang, but in Fujian, Huang is pronounced as ng. Alright? So NG is ng. So my name is, my surname, my family name is ng. Right? But I think some foreigners may find it difficult to pronounce ng, right? I was taught different versions when I was studying in the US. Some call me Eng, some call me Yang. But it's actually supposed to be ng, right? So some of my friends call me TK. When I write email, I write TK because Take Kim is my first name. Take Kim, 2 words. Okay? So okay? Now, so my office is set. Oh, I didn't update it, sorry. This is my old office. I forgot to update this one. 0208. So sorry. Com3 0208. Com3 is our new building. Okay. Now, there is a teaching assistant, and there's a TA. All right, and the TA will be in charge of grading your tutorial assignments. Okay. For tutorial classes, I will want to personally teach the tutorial classes. All right. So there are 3 tutorial classes. You can go and select the time slots that fit you, right? The tutorial will be in Com3, all right? Okay, so please update my office address, Com3 0208, right? Now, the tutorial slots, Thursday and 2 slots on Friday. You just need to attend one of the slots, all right? And then if you have questions, ask me during the tutorial. If you have more questions, you can come to see me in my office, all right? Final exam will be on the 27th of April, right? So tutorial assignments, there will be a few tutorials, and I intentionally put the weightage low because tutorial is for you to learn, right? I encourage you to try it out and learn and understand whole thing. So 20%, project carries 30%. Project will be individual projects. Okay? Individual projects because in the past I have group projects, but I find that some groups the contribution is a bit lopsided. Okay? And final exam 50%, as I mentioned just now, final exam will be open book, right? So there is no need, and there is absolutely no need to memorize anything. You can bring your book, you can bring your notes, everything into the exam form. Okay? So, as I mentioned just now, I'm going to flash to you some of the example mathematics that we'll be using. You cannot freak out when you see this kind of equation. If you freak out when you see this kind of equation, try to learn it. Okay? If you cannot learn it, then you shouldn't be taking this course. Right? You have integration sign, summation sign, the limits of the summation, limits of integration, and then you have the sine, cosine, right? And then okay, there's something that I'll
I'll have to ask you to accept it if you have not come across. There's something called Euler's formula. And say what is the Euler's formula? You must straight away tell me it's cos theta plus j sin theta, alright? Right? It must be that good, huh? It must be inside your. If you're not familiar with this, then some familiarity with some of these things will help you to accept the equations, right? And then this J. Okay, when you are in the mathematics department, how do you represent an imaginary number in a complex number? Use I, right? Right? Now, when you do signal processing, you always want to use J, you don't use I. Because signal processing originally was developed for very engineering stuff, right? And in engineering, I is reserved for current, electric current. Okay? So I is already taken. So the engineers use J, alright? And then for a course here, I want to use J also because J is easier, is clearer. I sometimes can be mistaken as 1, right? So I will use J. So every time you use J, you see a J means imaginary number. Okay? How many of you do not know what is a complex number? Okay. So you have equations like that. I just went through the slides and then pull out those equations, right? So equations like that, and then omega equal to 2 pi f. How many of you studied physics before you come to university? You have the radio frequency, right? Radio frequency, right? Radio frequency omega equal to 2 pi f, right? You know about this, right? It's the same thing here, right? Right, 2 pi is 1 round, right? So how many cycles per second means how many rounds per second? So it's multiplied by 2 pi. Right, turn it into radian. So we use omega and use f interchangeably, right, with a factor of 2 pi. And then you also will come across something called a delta function, which is nothing more than just nothing. You know, delta function in the discrete time is just a 1, right? That's a spike. Okay, and these are MATLAB code, right? Now, in some, I'm going to do something differently, based on my experience in the past. I think this year I'm going to do something differently. Some of the concepts, because I know that most of you are computing students, and computing, or all are computing students. When you are in computing students, you like to see code, right? Right? So I'm going to use MATLAB to explain some of the concepts. Okay, I'll be doing the coding and show you the concept effect and that sort of thing. And when I use MATLAB, don't need to copy, because if I use any MATLAB in class, at the end of the class, I'll send you the code that I use in class, alright? Okay, then you can run MATLAB on your own and test it out. Okay, that one may help you to understand a bit better. So, and then we talk about frequencies for audio signal, right? But frequencies happen in visual signal also. Can someone tell me, you know, when you talk about audio signal, right? When you say do, re, mi, fa, so, you can attach a frequency of 400 hertz, 500 hertz, that sort of thing to it, right? Right? How many of you have not heard of hertz? The unit for frequency. When I drive every morning, I like to tune to 88.9 megahertz. That's BBC. Right, BBC channel I like to hear or listen to it because BBC is actually very interesting. So BBC is 88.9 megahertz. Okay? So you have been using hertz all the while in your life. When you tune into all radio and things like that, right? Right. Hertz is a unit for frequency. Okay? Okay? When sine wave like that, you can say maybe within 1 second you have a sine wave, or 1 period is 1 hertz. When you have sine waves that vibrates a lot, that's many hertz, understand? Okay, hertz is the notion of how many cycles per second. Okay, now when we listen to audio signals, our eardrums vibrate, right? So the audio signal came in, vibrating in the air, and vibrate our eardrum and our bone and things like that, right? Ear bone, and that's why you got audio signal, right? So it's all through vibration. You can explain this vibration, which is like periodic, right? To using hertz, the notion of hertz. Now, a lot of people cannot understand why in images we also do frequency analysis, because what's the idea of hertz here? Can anyone tell me how we should interpret frequency in images?
Color.
Sorry?
Color.
That's a good answer, but it's not the answer that I was looking for. I'll explain why is it a good answer. Who else? Yes?
Variation of color.
Variation of color, that's a good answer also. Closer to what I was looking for. Who else?
The wave loss.
Sorry?
The wave loss.
Wait?
The wave.
The wave?
Yeah, the wave loss of the color. The spectrum.
The wave?
The wave loss.
Oh, the wavelength. A wavelength is related to color. Okay? Now, you studied physics before, right? Wavelength and frequency are actually inversely proportional to each other, right? Right? High frequency means a lot of cycles per second. That means the wavelength is very short, right? So when you say the notion of images and frequency, and you say it's color, that is the correct answer, okay? But that's not the answer that I was throwing at. The color, our eyes can see, our eyes perceive color because we have 3 types of receptors, color receptors, RG and B, right? Red, green, and blue. So, and then it's a combination of red, green, and blue, just like our TV screen, that gives us the notion of the variations of color. And RG and B, if you plot it out in the frequency, in terms of wavelength, you separate them, but a wavelength is inversely proportional to frequency, and therefore you can explain the different color using different frequency, right? Okay? Yeah. So that's a good answer. If you look at the color aspect, and then that is a good explanation. But in terms of digital signal processing, whether you are red or green or blue, when it is represented in an image, it is all 0 to 255, right? So that kind of wavelength kind of notion is no longer there. You see what I'm saying? Yes? RGB is still represented as 0 to 255, 0 to 255, 0 to 255. Okay? Okay? We don't represent RG and B using different set of numbers. Okay? So in digital image processing, the notion of frequency that we are talking about is not about the color, the wavelength. It's about how fast the pixel changes. Understand? Okay? For example, if you are looking at this patch here, it's all flat, right? No change, right? No change. So we want to say the frequency here is 0. But if you look at the cross here, there's a huge shade, right, from dark to bright, right? You want to say a lot of, there's a very high frequency component, understand? Okay? So the frequency that we are talking about here in image processing is about spatial frequency, the variation in space, understand? Spatial frequency, all right? Variation in space, okay? So this notion of frequency is actually very important. Okay, in commercial work, people do it, but if you are like professional working, you say satellite images, right? In satellite images, when people sell you satellite images, what want to tell you what is the resolution, meaning how fine can I see. Okay, 1 pixel is how big a piece on the ground, right? If 1 pixel covers a big piece on the ground, the resolution is coarse or fine. Coarse or fine. Coarse, right? You want every pixel to be very fine, right? Then it's high resolution. And you can use the notion of frequency to explain this, right? The simplest way to think of it is, you know zebra crossing, right? Black and white strip, right? And whether you can still differentiate the zebra crossing from that height, right? Gives you a notion of what is the resolution, okay? And to describe the kind of variations, black and white, uses the notion of spatial frequency, okay? So in other words, in time, when you talk about audio signal, it's about temporal frequency because the x-axis is time, right? Variations of time. In images, you talk about spatial frequency, right? The frequency is not horizontal axis, not time. It's actually x and x or y. Okay, the spatial domain. All right. So this is actually Fourier transform equation also. It's just that it's two-dimensional. Okay? And you must be familiar with things like if you have an exponential, right? Multiplied by an exponential, right? The result is the same exponential, you just add up the indices, right? Remember this, right? So guys, what I'm trying to tell you is, in this course, there are a lot of mathematics, but it's not those mathematics that you have not learned before, right? A lot of time, people have forgotten, right? And so I flash this set of slides to you, and if you find that you are a bit a lot of things you've forgotten and things like that, make use of this few days to understand. Okay. There is something called convolution. Okay. How many of you have learned deep learning before? Neural network, convolution neural network. Okay. For those of you who learn convolution neural network, I want you to flush away your neural networks, the convolution neural network, because it is a very loose way of using the word convolution, understand? Right? Convolution neural network actually makes use of the essence of convolution. Convolution neural network was invented in the early 90s, right? For handwritten character recognition by a French person who just won the Turing Award last year. Yann LeCun. Is that the correct pronunciation? Okay, come on. Okay, Yann LeCun, right? He won the Turing Award together with two other professors. One of them is from Waterloo. Someone from Waterloo here, right? Yeah. Right? But the convolution neural network was invented then, early 90s. But when you do CNN, there's something called strike, right? Right? You jump around, right? Strike. There's no such thing as strike in the convolution or the strike. You have to shift faithfully one by one, understand? There's no such thing as jumping, huh? Right? So convolution neural network makes use of the essence of convolution, but it's actually a loose implementation. Okay? So don't be corrupted by what you learn in CNN, right? Okay? Now, so we do something called convolution. And if convolution is actually a very, very, very powerful technique, right? That can save you lots of lines of coding, understand? Okay, if for certain things, for example, if I want to do pattern recognition, I want to match this pattern with another pattern. If you do it based on the image domain, spatial domain, you have lines of code like that. Here, if you use Fourier, right, just one line can give you the answer. All right. So it's something worthwhile learning. Okay. Okay. We will also talk about something called impulse, the delta here, right? Remember just now you saw delta also, right? Now delta, when you talk about discrete time means the time is not continuous. It is 0 unit, 1 unit, 2 unit of time, nothing in between, right? That's discrete time. In discrete time, delta function is just 1. Now, in a continuous time domain is something strange. There's something that you just have to accept it. Huh? The impulse, when you say the impulse, right? What is the impulse? What's your name? Wei Jie, I give him a punch, right? And then Wei Jie will shout, right? Shout very loudly. Okay? My punch to him is an impulse, understand? And then it's so heavy that Wei Jie will shout through the maximum it can get, infinity, for example. Okay? Okay, you just shout and then you shoot up, right? Impulse and impulse response. Think of it that way, alright? Impulse, if I give you a punch and then your impulse response shoot up. Okay, you shout and then that's your impulse response. Now, when you talk about impulse, right, it is like that which is shocking, right? My punch to him. My punch to him is like infinite strength. Okay, infinite strength. Punch. Within a short period of time, right? So the magnitude of the height of that arrow is infinity. Okay? The width of that arrow is 0. It's close to 0. Understand? Okay? Mathematicians tell us that when you multiply something very, 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 very close to 0 with something very, very, very close to infinity, you get 1. Okay? So just accept that that's the definition for the impulse that we're talking about. Something very narrow with very high value. You multiply, you treat it as like a rectangle. You look at the area under the curve, it is like 0 multiplied infinity equal to 1, right? Okay? So that's the impulse, the concept of impulse, right? So, the details we will talk about it next time. And then, okay. So cost of view. So any questions so far? Are the maths very daunting? They're okay, right? Okay? They're okay. So I hope you can enjoy this course, and I can assure you actually it's something very useful for you to learn. Okay? You want to do speech recognition, you want to do image processing later, you need this kind of knowledge. Right? So what are media? This is introduction to media computing, right? So we want to be able to handle audio signal, image signal. Okay? We also want to be able to handle video. Video is nothing more than pictures spread out in time domain, right? Right? So the handling of that is actually quite similar, right? Somewhat similar with images, 2D images. Now we will also spend some of the time talking about text processing. Text processing is another big topic. We can only, for the course, because this is level 2 course, right, we can only do some very rudimentary one. For advanced text processing, you have to take courses like NLP, Natural Language Processing. There's another Prof. Teaching this, right? Prof. Witao. He's an expert in natural language processing, right? So if you are keen on processing text images automatically using human natural language, then you want to attend that course, right? The text natural language processing course. So in signal processing, as I mentioned, we will start from scratch. We will understand what is basis function. How many of you have done linear algebra? Okay, you know what is basis function, right? You know what is a dot product? Okay, I'll explain what is basis function later. Okay, and then we do something called Fourier transform. We must know what is the notion of frequency resolution. A lot of people, including engineering graduates, they go out, they can apply fast Fourier transform and all that, but they do not know how to interpret it well. Okay? We have to know something about frequency resolution, and then the concept of linear chip invariant systems, convolution and correlation. Right? Convolution and correlation are actually quite similar. Engineering people will only study convolution, they seldom study correlation, but actually mathematically they're quite similar. Right? And correlation is actually quite useful for pattern matching. Right? And then sampling theorem. I will not do factorization techniques here in this course. I think it's too much for this course. So factorization techniques I'm going to take out. Now, there's something that we want you to know for this introduction of media computing, and that's the notion of data compression. I'm sure you have heard of JPEG, MPEG, that kind of things, right? The purpose for JPEG, when you take a picture, when you use JPEG, it means you compress the file size, right? But there's no free lunch, right? There's no free lunch. The moment you compress from here to here, you're going to lose some details. Okay? And in order to understand the compression process, you also need a bit of frequency. And also, we are going to do something called lossless compression also. Right? Lossless compression is like I reduce the file size, I maybe 1/3, and I don't lose any information. That's lossless. Okay? Right? And then some application example. So you can see this is the course overview. Okay? Any question? Now, go and install MATLAB. As I mentioned, this is a very expensive software. Go and install it. It's available for download even for exchange students also, right? And, download it and install all the toolboxes if you want, right? Because we already paid for the license. Okay? Now, some general knowledge stuff, right? You know, at home I have the history channel also, and sometimes I'm actually quite fascinated by, you know, the Inca, the Maya, you know, the ancient civilization, right? They have a lot of very ingenious way of say communicating messages, right? So this is one example, right? The people, right? That's from Inca Empire, and then as society progresses, people invented words and printing materials. Initially, you write it on the animal skin, right? Then you have paper, right? And then you invented printers, printing, right? And then comes the era of radio, right? Radio broadcasting. And then you have audio and video, right? And things progress, right? Things progress. So and then we have internet. And now, of course, we have the ChatGPT, right? So there was there's some discussion how to deal with it, because you have to live with the new technology, right? But at the same time, you also don't want students to rely on those things that they cannot do other things, right? It's like ChatGPT and then do everything. So it's a challenge. But for our course, I don't think we have that problem, because ours is very, very customized. I'm very focused, very customized. I don't think ChatGPT. I hope ChatGPT cannot do much. Right? And learning image processing, image processing can do a lot of wonders, right? You know, you watch the Harry Potter series, right? Harry Potter has got a lot of very nice visual effects, and behind it is all computer vision technology, right? So, so all these things require storage medium, right? And when you require storage medium, you need compression technology, because you don't want to store things unnecessarily. For example, just now I mentioned to you that without losing any information, you can easily compress things by maybe 3 times, right? Lossless compression, right? So you don't want to store things in the raw format. Okay? So transmission technology requires the knowledge of you always, I'm sure all of you have come across the notion of bandwidth, right? And then you use it very loosely also. For example, if I'm too busy, I say I don't have bandwidth to do it, right? Right? And bandwidth is one notion that is very important for communication industry, right? I talk about the BBC, right? BBC occupying 88.9 megahertz, right? But it's not just 88.9 megahertz, it has got plus or minus that piece of the frequency range that allows them to transmit to my car, right? 88.9. So that is the bandwidth. Okay, that's the bandwidth occupied by BBC, right? So within the band itself, you chop it down into different segments, and every radio station makes use of some segments, and you have to pay for it. And some segments are actually occupied by the police. So if you tune your radio, sometimes you can tune to police radio car, police car, right? Right? I never do that, but you watch the movie, you can see that, right? Sometimes, right? So that's the notion of bandwidth. So in order to know how to explain bandwidth and things like that, you still need to go back to frequency. Bandwidth is a frequency concept, all right? And then processing technology, signal processing. So in other words, we need to see things in frequency domain, okay? And we need skills to deal with big data, okay? So I let you listen to some music, and then because it's a 2-hour lecture, but usually at the end of 1 hour, we have a 5 minutes break, then we come back, right? Right? Before you go back, go for your break, let me listen to some music, and then, right? Now, I like folk songs. Okay, I like folk songs, and I like folk songs from different countries, different regions, right? So some examples, I pull out some folk songs, and this one that I'm going to show you is actually from Taiwan. It's a Taiwanese folk song, okay? And I literally break the piece of music into sine waves and cosine waves, understand? Using Fourier techniques, okay? Break it into sine waves and cosine waves. And then I recombine them to recover the song. And I show you that if I recombine only the low frequency component, you can't hear much. If I increase the frequency components to higher frequencies, then you begin to listen to music. Understand? Okay? So I let you understand. I let you hear the final song. Okay? This is the. Oh, I didn't connect my. Okay, this is the original song. I decompose and then put it back again, right? That means I strip the music, the piece of music, the audio signal into sine wave and cosine wave, and then add them up again. And this is what you hear, okay? No loss in the quality. Now, if I only use the low frequency components and add them up, this is what you hear. Okay, now up together, you can hear the best quality here. But if you only add the sine and cosine of very low frequency, that was what you hear. Okay? Now let's go to CS30. I use more and more frequency now, right? Including the higher frequency, this is what you hear in 30. Okay? So you begin to hear the music already. If I add 100 of that, 100 sine and cosine. Right? Now, if I add all 500 over is what you hear, right? You heard 584 by your head. Just add the 500,000. 500,000 sine and cosine waves add up together. 500 sine and cosine waves add up together. You can hear this. 500,000. I think I pressed the wrong one. I pressed the wrong one. It shouldn't be like that. It should be the entire music, understand? So it goes to show that actually whatever we hear, not just music, my speech also, you can always decompose into sine and cosine. You know, it's amazing. And then when you add them up together with the correct weighting, that means 1 hertz I weight more, 2 hertz I weight it less, or that sort of thing. Once you get the coefficient of the weighting correct, you can form any kind of signal that you hear everywhere. Understand? Okay? Yeah, Daniel.
Yeah, can I ask a question?
Yeah.
So basically, compression will cause the quality to be lower, is it?
This is not about compression.
Oh, okay.
This is about choosing the set of audio signals, the sine, cosine, which you add up together.
Because that time I watched a video on why home music they used to sound better. You know that when you call the phone, right, then they hold. I'll email you the link later.
You're not right in saying that has related, is related to compression, but I don't want to confuse the class here. All right. So it's 11:08 now. Let's come back and resume the class at 11:15. Understand? 11:15 to come back, and then we resume the class. All right. Yeah. So we take like 12 minutes break. Basics of MATLAB, in case those of you who are not familiar with it, all right? And at the same time, going to introduce some very basic concepts about linear algebra, okay? Now, MATLAB, this is, when you fire out MATLAB, this is the thing. Okay, just some tips. If you are a graduating student or if you are an exchange student and you want to install MATLAB, right? Make sure you don't install it in a computer that you're going to throw away next year. Okay? Because when you install using the NUS license, it's going to stay with your computer. You cannot transfer. Okay? So if you really want MATLAB and in your system or any other software that you download from NUS, get a new machine. Okay, at least can last for a few more years. Right? Now, so MATLAB is actually a short form for matrix laboratory. So it's very useful for matrices and vectors. And vectors is actually a particular form of matrix, right? Just a one line kind of matrix. Okay. Now this is when you go to MATLAB, right? You can actually say new. You can press new, and then they'll give you a new workspace here, right? And then you can actually define your vectors and matrices quite easily. It's a lot more convenient than Python. Python, NumPy is a pain. Okay? In terms of matrix multiplication and things like that, you need to key in a lot of things. MATLAB is a lot more convenient here. So let's say if I have A, can you see it's too small, right? So you can see it now, right? Okay. I can see it now, right? It's big enough. That's the biggest font I can say. Okay? So you can say A equal to, say, 3, 4, 2, 5, 4. Right? Okay? Okay, you can actually do it at the command prompt here. Let's say A equal to 3, 2, 5, 4. Right? And then you press return, it'll tell you that you have a vector that is 3, 2, 5, 4. Alright? Okay? Now, you can continue to type here. You can continue to type here at this command prompt. But sometimes you want to save all your commands, right? You don't want to be repeating everything, right? So you can collect them as a MATLAB file, .m file, okay? So in other words, instead of typing at the command prompt here, I could actually, see just now is this, right? Just now I say, I new script, right? And I can put it here. Okay, and then this is untitled, and I say I want to save it. I save it into the file, say lecture 1. Okay, so it's lecture 1. Okay, so instead of typing all your commands on the command prompt, you put it in the file, and then you run it, and then you get answer, right? Now, if you add a semicolon, then it will still execute, it's just that it won't print it out. Okay, you execute but it won't print it out. Okay? Now, useful command to do is whose. Whose is actually to show the variables in the memory now. Okay? So if I run it, right? If I run it, you see, let me clear all, right? Let me clear, because I was running something else earlier on. So let me clear all the variables. Okay, let me run it again. Right? So the memory only shows A, which is a 1/4 vector, right? Okay, so WHOS is a very useful command to let you check what are the variables in the system. Okay, now so for the purpose of this demo, I'm going to remove the semicolon. Okay, as I mentioned, you don't have to. If you have MATLAB with you, you can type with me. It's fine, right? But if you don't have MATLAB, don't worry, because I'm going to give you the file later. All right. So you run it. Right, A equal to 3, 2, 5, 4. And then it is a 1/4 matrix. 1/4 matrix is also known as a vector, right? Okay? Now, if you want to say B equal to A transpose, okay? Then you find that the output is this. A is 3, 2, 5, 4, B is 3, 2, 5, 4. How many many of you do not know what is a transpose? Transpose of a matrix is, transpose of a vector is like when your row vector becomes a column vector becomes a row vector, right? Right? No. In matrix, it's like, you know, row become column, column become row, right? I mean, matrix transpose. So you have to be familiar with the transpose command. Now, in MATLAB, remember, in MATLAB, right? This is commissioner. Never mind. This, okay, I give you. If you want to do transpose, right? You use just now you use this also can, right? Right? But when you're dealing with complex numbers, it will give you transpose and a complex conjugate. How many of you do not know what is a complex conjugate? Complex conjugate is like A plus JB is a complex number, right? Complex conjugate is A plus JB becomes A minus JB, you understand? Okay? Okay, so when you do that, MATLAB will give you the complex conjugate version, so be careful. So every time I want to use transpose, I use a dot. That's the safest, understand? Dot will not change your sign. Okay? So this is for transpose. Right? Now, if you do B times C equal to B times A, can you do that? Can you do that? Can you do that? No. Why? Because the dimension doesn't fit, right? Right? So if you do that, then you crash. Oh, it doesn't crash. Oh no. Okay. It's transpose. Oh yes. It doesn't crash. It only gives you a matrix instead. A vector this way, multiplied by another vector this way gives you a matrix. It doesn't crash. Okay, it will crash only when it's a 2D matrix. I'm sorry about that. Right? So it becomes a 4x4 matrix. Okay, it doesn't crash. Now, if you want dot product, then you should do D equal to A times B, right? Dot product is row vector multiplied by column vector. Then you see this, right? D is 54. Okay, dot product. Okay, so it's that simple. Okay, it saves you a lot of typing compared to if you were to use Python. Okay, now since I got the matrix C is a matrix, right? It's a 4x4 matrix, right? I can do inverse of a matrix. E equal to, I can use a small case also. Small case inverse of C. Okay, right? And then inverse of C gives me infinity. Can someone tell me why? Yes?
No inverse.
There's no inverse. Why there's no inverse?
Determinant is 0.
Sorry?
Determinant is 0.
Determinant is 0. Why determinant is 0? What's the other way of saying determinant is 0? Have you come across the concept of a rank of a matrix? Rank of a matrix, if you have 4x4 matrix, if the rank is 4, means it's full rank. Okay? Full rank means determinant is not 0. That's inverse. Alright? Okay? In this course, we don't need to go into the range space kind of thing, the space concept, the subspace concept. We don't need to go into that, but if you do some image processing stuff or some advanced logic stuff, you need to. But I think we can. If you don't know what is rank, it's not too bad. Don't panic. Okay. Now, there is a linear algebra theory that says when you multiply two things together, right? When you multiply two matrices or vectors together, the resultant answer, the rank cannot be more than any of the component matrix, understand? So for a vector, what is the rank of a vector?
1.
1. Okay? When the rank of vector is 1, that means when you multiply two vectors together, the matrix C that we got is rank 1 only. And rank 1 only, you have determinant 0, you cannot have inverse. So when you use MATLAB to do inverse, they give you infinity. They give you either infinity or they just fraction. Okay? So in other words, if you want something that is invertible, let's say I use E equal to random number 5 by 5, for example. Okay? Then F equal to inverse E. Now I should have, because it comes with that I use random number, I'm so unlucky that it doesn't have inverse. Right? So you can see that E is this, right? Random number, 5 by 5 matrix, and then F is the inverse of E. Right? They give you the inverse, and then if you don't believe, you say, if you don't believe that this is a correct inverse, you can say, you can just multiply E and F, right? And you should get an identity matrix. Right? This is an identity matrix, right? Okay? There's minus 0 point something. Okay, in computer science, in engineering, 10 to the power of minus 16, 1 times 10 to the minus 16 is 0, understand? In computer science and engineering, it's 0, understand? In math department, you'll kill us. Okay? but here, we go for, a lot of time, we go for approximation, right? And then because of round-off error, because of numerical computation, things like that, when it's supposed to be 0, sometimes they give you 0. Yeah, or when you see 10 to the minus 16, think they're 0. Okay? So these are a few common MATLAB commands that you use, and then you can actually create complex numbers. Okay? Okay, complex numbers. Let's say G equal to 1 plus 2i. See? 1 plus 2i, right? Complex number. Understand? Okay? And also, MATLAB recognize that J is also a complex number. So if you want, you can actually put H is equal to 2 plus 3J. It's the same, huh? Understand? They will still recognize the J as a complex number, the imaginary number I. Alright? Okay? Now when you deal with complex number, one common thing that we need to do in this course is to do the complex conjugate. And in MATLAB, you can do complex conjugate easily. Okay? And that is complex conjugate. Let's say H, and then I don't want to use I because then it's confusing. But even if I use this one, right? Conjugate of H, for example. Okay. So you see, H is this, I is a conjugate of H, and then you get that. Understand? Okay. Alright. Now, there are other things like there are common math manipulations like the modulus, absolute value, that sort of thing. You can try. Okay? If you don't get the magnitude of a complex number is absolute. Okay? Let's say J equal to absolute value of I, for example. See? Absolute value of complex number, you know, right? Complex number, real part, imaginary part, square plus square, square root. Right? It's the hypotenuse, right? The length of the hypotenuse, right? Okay, so MATLAB gives you very simple keystrokes to get what you want. So for that reason, for this course, I use MATLAB. Okay, and you should get used to it. Any other things that you want me to show for MATLAB? Plus, minus, multiply. You can do some some advanced stuff also. Although we don't need it, I don't think we need the log here. We may do for text. Yeah, for text we may need a bit of eigenvalue. How many of you have not heard of eigenvalue and eigenvectors? Eigenvalues and eigenvectors. Okay. It's okay. It's okay. I appreciate the feedback. All right. If you don't understand, just let me know and then I can explain it. Okay. Now, eigenvalues and eigenvectors. Okay. This is the definition for eigen decomposition. Let's say if I have k equal to a random number of 3 by 3, for example, 3 by 3. Okay, a matrix of random numbers 3 by 3. And then I want to get the eigen decompositions of k. Okay? Okay? So what? So what it means is this is k, right? And then this is eigenvectors. Eigenvectors, three eigenvectors. They happen to be comprising complex numbers. Okay? Okay? But for our case, I believe we will be dealing with something called symmetric matrices. When you are dealing with symmetric matrices, you won't see complex numbers like that. So let's go and simplify things. So k equals this. How do you create a symmetric matrix out of normal matrix? You can just do k plus k, this, right? K plus k transpose should give you the symmetric matrix, right? Yes? Yes? So now you get a real number now. So you get a real number for your B and your D. Now, D is the eigenvalue, right? Eigenvalue, these are the three eigenvalues. The diagonal gives you the eigenvalues, and then the three vectors gives you the eigenvectors. Okay? What this means is, what this means is this, if I use V, the first row. Okay, one thing about MATLAB is this, a lot of people make mistakes when they use MATLAB coming from other languages. Most other languages, you start your index from 0 or 1? 0. MATLAB starts from 1, understand? MATLAB starts from 1. So a lot of time people crash because of that. Okay? And the dot sign, the colon sign is the same as what you do for Python, right? The entire column, first column. Okay? First column, right? You print out the first column, and then you print out the vector first column multiplied by the first eigenvalue. Okay? Okay, and then you print out the k. See what happens. You need to print out k times the first column. Okay. See the same, right? So that's what the eigenvectors gives you. Okay, you take the first column, the eigenvector, you take the first eigenvalue, right? You multiply with it, and then for your original 2 by 2 matrix, you multiply with the eigenvector, they are the same. Eigen, if I'm not wrong, is a German word that means same, right? Anyone speak German here? Yes. Yeah. Okay, it means same, right? Eigen, it's same, right? It's same, okay? So the matrix multiplied by the eigenvector equal to lambda times the eigenvector. Okay? And And you can do that for the second one also. You can do that for second row and third row also. You can do that for second row and third row. Second row. And third row. Okay, these are the same value. Alright, so that's the definition for eigenvectors and eigenvalues. Okay, so these are the basic maths that you need to know. And then for that, I think with that exercise, I hope you have got some feel of how MATLAB works. Okay, and you are going to do that, you use MATLAB for your assignment also, for tutorials and projects. And there are many other things like you can write files, read files, that sort of things, right? There are a lot of toolboxes, library toolboxes that you can use. Yeah, one more thing, very useful for your tutorial. You know, you run and then you print out like that, right? How are you going to submit the result? How are you going to submit the result? There's something very useful for MATLAB. Useful command, and that is diary on. When you set the diary on, you create the file and keep all the output that is spit out, okay? Right? And then at the end of it, you better say diary on. Okay? And you run it. You see now, right now I have one following, right? This is a temporary file. If I run it, then you create a file called diary here, right? And the diary actually will tell you, give you the output, understand? Right? Matrix is singular, right? That's how we take the rank one. Okay? So it gives you the output, understand? Okay? But be careful, before you submit, because diary file, when you on and off, there's only one diary file in the directory. Every time you run it, you just append your results to it. Before you submit your tutorial answers, make sure you delete your diary file first. Otherwise, the TA will be dealing with all your history of your entire history of your development, understand? Because you just append to it. So delete your diary file before you submit it. Okay? Right, so I think that's about it, the very simple commands to you. You can use for loop and if that helps also. You can use for loop, for example. Right, the for loop is this, right? This is for, say, m equal to 1 to sines of k1. Okay? For n equal to 1 to sines of k2. Right? Sines of k1 means the row dimension. Sines of k, remember everything is matrix, right? So it's like row and column. Sines of k1 is the row, number of rows, and sines of k2 is the number of columns, right? So then you can say print. Print, no, you don't need to use print, sorry. You can just write m and n, just write, just print the indices and then you say k, n, and n. Okay? And then you need to use the n for the for loop, okay? And then you run it, okay? And then now you look at the diary file, at the end of it, output, right? Right, K11 is 1, 2, 1, 3, 1, 4, understand? Sorry, 2, 1, 2, 3, 2, 4, and up to 3, 3, understand? So that's how you do the for loop, and you can use if also, if then else also. Okay? You can use if then else. Let me try, let me write something here. font, you don't need to indent it, you're still okay, but you still want to indent the space to look nicer, right? Right? So you only print out when n equal to n. Okay? So run it. And then I look at the diary. Right? You only print out when n equal to n, understand? Okay? So simple commands like that, you don't need very advanced commands for this course. Okay, just do for loop, if, then it's more than sufficient to do your tutorials and also your tutorials and also your project. And of course, there are very nice plotting commands also. Very simple plotting commands. Alright, so it's 11 about 11:45. I'm supposed to release you now. Any last question from anyone? If not, I'll see you next week at 10 o'clock. Okay. Okay, thank you for your attention.
The grade actually matters for